and video 12C, where we are going to do an example problem using this new formula that we have just learned. So this is example 12.4. Example 12.4. And there are several steps involved, so let's get started and keep a positive attitude because this stuff is fun. Okay, so example 12.4 says, a gas mixture contains 40 grams of carbon monoxide and 10 grams of nitrogen dioxide. Now right off the bat, because they're giving it to us in grams, I just know we're going to have to convert grams to moles because mole fraction compares the moles of the gases present, not the grams. Okay, so we'll keep that in mind. If the total pressure of this gas mixture is 1.2 atmospheres, what is the partial pressure of each individual gas? So what we are looking for here is the partial pressure of carbon monoxide and the partial pressure of the other gas present, which is nitrogen dioxide. And what do we know? We know that we have 40.0 grams of carbon monoxide, and we know we're going to have to convert that to moles. And we know we have 10.0 grams of nitrogen dioxide. And we know the total pressure, P, capital T, equals 1.2 atmospheres. All right, so let's get started with converting those grams into moles. So 40.0 grams of carbon monoxide. We are just so good at this by this time. We put grams on the bottom of carbon monoxide. We put moles on the top. Then we fill in the numbers. For 1 mole of carbon monoxide, there would be 12 grams for the carbon and 16 grams for the oxygen. So that would be 28.0 grams of carbon monoxide. So 40 divided by 28 is 1.43 moles. 1.43 moles of carbon monoxide. And then we'll do the same thing for the nitrogen dioxide, NO2. 1 mole of NO2. How many grams is that? That'd be 14 plus 16 plus 16, which is 46.0. So we end up with 0.217 moles of NO2. All right, now if we want to find the partial pressure of one of the gases that's present, we can use this equation. So we have to know the mole fraction for that particular gas, and we have to know the total pressure. We know the total pressure, we know how many moles there are of each gas, so we can figure out the mole fraction for each one. Okay, in order to figure out the mole fraction, we have to know how many total moles are present. So now we're going to add these two together. So total moles in the gas would equal 1.65. 1.65 total moles are present. Okay, so now we're going to figure out the mole fraction for each gas that's present. So the mole fraction for carbon monoxide would be 1.43 moles divided by 1.65, the total number of moles, equals 0.867. So now that we know the mole fraction for carbon monoxide, we can plug it into this formula and figure out its partial pressure. So its partial pressure would be equal to, we'll put P of CO, would equal the mole fraction of CO, which is 0.867, times the total pressure, which we were given was 1.2 atmospheres. So the partial pressure for carbon monoxide would be, actually it comes out to 1.0 ATMs. And we're going to quickly figure it out for nitrogen dioxide because now I have a little helper in my presence. So I'm going to erase this. Are you my helper? Okay, real quickly here, you can draw with green. Just keep your back to the camera so I don't get in trouble with YouTube. Ha ha ha. Okay, so then the mole fraction for NO2 would equal the number of moles of the NO2, 0.217, divided by, we had 1.65 total moles, which was 0.132. So that's the mole fraction for NO2. This is very unprofessional to have my 4-year-old here. Very sorry, but we're just going to keep going. And then the partial pressure for NO2 would equal, Natalie, can you say 0.132? It would equal its mole fraction times the total pressure, which is 1.2 atmospheres. So if you do that multiplication, you get 0.16 atmospheres for the partial pressure of NO2. Whew, we made it. Just a couple seconds there that were slightly unprofessional, but I trust you will forgive me, and I hope you understand this example. Bye-bye.